All righty. So we're talking about titrations. So a titration is a very specific kind of chemical procedure, and it's a process where we are neutralizing an acid with a base, or a base with an acid, if that makes sense. When you neutralize something, you cancel it out. So what we're doing here is it's an analytical process. So you take the concentration of a known base and you take a certain amount of it, a known volume, and you use that to neutralize a known volume of an unknown concentration of acid. So you use an acid to neutralize a base, or a base to neutralize an acid. It's a process. The reference tables have a formula, and the formula here, all right, is MA times VA equals MB times VB, or the molarity. MA is the molarity. Molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Molarity, remember, is measured in moles per liter. Volumes of acid base, volume is measured in either liters or milliliters. But I also want you to be aware of a liter is also equal to something called a cubic decimeter. If you can visualize a decimeter, or 1/10 of a meter, make a cube of it. That is that space, that volume occupied by that is defined as a liter. Similarly, a cubic centimeter, that is what a milliliter is. So you hear on the doctor shows and those different things, they talk about giving someone 50 cc's of epinephrine or something. They're talking about a volume. Cc's is a cubic centimeter. Cubic centimeter is a little bit more accurate than a milliliter, and I won't go into the reasons for that. But cubic centimeter is the desired, the international system method, or cubic decimeter. When they talk about ventilators and they talk about how much air someone needs, they'll talk about cubic decimeters as opposed to liters of oxygen. So those are just two terms that you need to know. Um, Titrations also use very, very specific equipment. You're going to use something that's called a burette, and that's this thing over here. This big, long, tall tube is called a burette, and it's open at the top. It's got a little valve here at the bottom called a stopcock, and you read it from the top down. So 0 is up at the top, and 50 is down at the bottom, and there are small graduations in between it, and you can generally measure a burette very, very accurately to 2 decimal places. And so that's each one of the indicators is going to be either a milliliter or a tenth of a milliliter, and so you can go beyond that to get really, really accurate. So that's a burette. You also use this thing here down at the bottom. It's called an Erlenmeyer flask. An Erlenmeyer flask is used because you can swirl that. You can swirl it by hand, or you can put a stirring bar in it. It'll stir, and the stuff won't splash out. If you've seen the coffee cup that I sometimes use, it's kind of shaped like an Erlenmeyer. And the reason is that stuff, as it spins, as it flops around in there, or as I walk around with my coffee cup, stuff doesn't splash out. This is a much more stable volume container versus a beaker, which had straight sides. So you take your burette, you fill it up with some of your known concentration of base, and you're going to drip some of that down into here. Now, the acid down here at the bottom, or you could have acid up here and base down at the bottom, whichever, but you're going to use something that's called an indicator. We've talked about indicators, and an indicator tells you when you've reached the point of neutralization. Typically, you use phenolphthalein, because phenolphthalene's color abruptly changes from either clear to colorless. In an acidic solution, it's clear. In an alkaline or basic solution, it is pink, bright pink. So that's what you use. You set it up using a special kind of stand, a ring stand with a special, it's called burette holder, cleverly named. and you slowly drip some of this stuff down here into your bread. Now here they're showing, looks like a beaker with a stirring rod. That is not the preferred way to do it. It's preferred to use an Erlenmeyer flask and swirl it either by hand or with a magnetic stir bar. The other thing you have to use is a pipette. And a pipette is like a burette. It's, again, measured from the top to the bottom. It's got a little pipette bulb at the top. And what you do is it's kind of like a giant eyedropper that's graduated that you can measure with it. So you suck up liquid, and then you slowly add the liquid, and you can determine exactly how much liquid you're going to add. And so that's some of the glassware, some of the specific equipment that you're going to use. A burette, an Erlenmeyer flask, a pipette, and an indicator. Okay? I'm going to ask you to do either the titration lab here in class or the virtual lab. The virtual lab is an excellent way of doing this. Pay close attention to the directions. Okay? Good luck.